Teen smoking. A Vermont study published in December 2001 by the American Academy of Pediatrics examined parental influence on teenagers' decisions to smoke. A group of students who had never smoked were questioned about their parents' attitudes towards smoking. These students were questioned again 2 years later to see if they started smoking. Researchers found that among the 284 students who indicated that their parents disapproved, 54 had become established smokers. Among the 41 who initially said their parents were lenient, 11 became smokers. So we have group 1 and group 2. So group 1, I will say parents disapproved. In group 2, the parents were lenient about smoking. So in group 1, 54 of 284 students started smoking. And in group 2, 11 of 41 started smoking. It says, what kind of design did the researchers use? So this is a prospective study. Prospective observational study. Okay, they chose these groups and decided to follow them and see what happened. They did not impose any kind of treatments. They were just watching. Write appropriate hypotheses. So we have a null and an alternative hypothesis. And our null hypothesis would be that the two groups, the proportion that start smoking in the two groups are the same. So there's no difference in the proportion of students who started smoking, whether or not their parents approved or disapproved or were lenient about smoking. And the alternative is that there is a difference. Okay? Are the assumptions and conditions necessary for inference satisfied? I'm going to actually move this part over here. So our assumptions and conditions is that they are independent, they are random. We have the 10% condition, the success-failure condition, and the independent groups condition or assumption. So it makes sense that the groups are independent. What happens in one group does not affect what happens in the other group. 10% seems to be fine in both groups. I don't think we're oversampling either group. And the success-failure condition, we barely make it in terms of the successes in group 2. We've got 11 out of 41, but that's still over 10 successes. And then, which means we have 30 who didn't start smoking and 54 and 230, that's bigger than 10. Independent means we're just going to have to assume that this is true, that maybe that when they selected these students, that they're not all a bunch of friends together. So we're going to assume that these groups within them, the individuals are independent of one another. And random, it seems that these were randomly selected. So, or we just have to assume that that's also true. D, it says test the hypotheses and state your conclusion. So, under the null hypothesis, P1 and P2, the difference is centered at 0, and the standard error is given by P pool Q pool divided by N1 plus P pool Q pool divided by N2, the entire quantity taken the square root. So what is P pool? P pool is the total number of students who started smoking out of everyone who we asked. So 54 in group 1 started smoking and 11 in group 2 started smoking. We asked a total of 284 in group 1 and 41 in group 2. So we have a total of 65 students who started smoking in total. And we have a total of 284 plus 41, 325 students total whom we asked. And that gives us a proportion, pooled proportion, of exactly 0.20. So our standard error is 0.2 times 0.8 divided by 284 plus 0.2 times 0.8 divided by 41. So calculating that out, and we take the square root of that, we get this standard error to be 0.0668. Alright, so we are centered under the null hypothesis. We are centered at 0. The observed difference between these, we actually haven't calculated our P1 hat and our P2 hat. So P1 hat is 54 divided by 284. About 19%. And then P2 hat is 11 out of 41. I'm sorry, I'm going to just 1901 and then 11 divided by 41 is 0.2682. So our observed difference is negative 0.0782. Alright, so we're at negative 0.0782, and our standard error is 0.0668. So our z-score is negative 0.0782 minus 0.0668. I'm sorry, not. Minus our mean, which is 0, divided by our standard error of 0.0668. Sorry. Again, the formula for z is y minus mu divided by sigma. So our y is negative 0.0782. Our mean is 0 divided by our sigma. So our z-score comes out to be negative 1.17. Okay, we are interested in the two-tailed probability. So we just have to find the area in one tail, and we multiply that by 2. So if we look up negative 0.117, or negative 1.17, we see that the area to the left is 0.121. Okay, which means the area over here is also 0.1210. So the total area, our p-value, is going to be 0.2 times 0.121, or 0.242. So this is going to be larger than alpha. It didn't specify an alpha, but if we just assume 5%, 0.24% is larger than 5%. So we fail to reject the null hypothesis. Alright, so I've run out of space to write out the answers for E and F, so I will just explain them. It says, explain in this context what your p-value means. It means if the null hypothesis were true, that there is no difference in the proportion of students who start smoking whether or not their parents approve, the probability that we would find a sample of about 54 out of 284 and 11 out of 41, the probability of us observing two samples with a difference of 7.8% between the two that probability is about 24%. So that we would observe that just by random chance. So it's not that unusual to observe such a difference just by random chance. So we do not reject the null hypothesis. We say, okay, well, we don't have enough evidence to say that there really is a difference. Part F asks, if that conclusion is actually wrong, which type of error did you commit? So if we made a mistake here, the type of error here, in that we did not reject the null hypothesis when we should have, that is a type 2 error.